Okay, if you're going to try to solve this equation and the word logarithms rings a bell, and if it's come up in class, then okay, put this aside for a second. We're just going to look at this quick little example. If we have log a to the b power, that's very useful because now the logarithm allows us to move that power that is here and put it as a coefficient. You can multiply the log a. So how does this principle apply here? The problem is that we're trying to get x by itself, and it's stuck in the exponents position. So if we want to use a new tool, we have to do it to both sides to keep the equation balanced. We take the logarithm to both sides. When you take the logarithm to both sides, that allows us to use that AB principle that we just saw. X plus 1 comes down, and now it's being multiplied instead of being stuck there in the exponents position. And notice how I put it in parentheses. We need to use the distributive property because this has to multiply to both of these numbers. So think of logarithm as your way of breaking the x out of jail. If it's stuck in the exponents position, you can use the logarithm to break it out of jail. And now we can solve this like a regular equation. There's always a lot of different ways you can go in math. In this way, I chose to divide both sides by log 2. Without evaluating these logarithms, I'm just going to subtract 1 from both sides. When you punch these in your calculators and subtract by 1, you should get x equals 2. And that makes sense because if x is 2, 2 plus 1 is 3, and 2 to the third power is 8.